The Moon as a Dwarf Star, a New Perspective on Helium-3 and Cosmic Origins. Abstract. This paper challenges the traditional scientific understanding of the Moon's composition and origins, particularly the presence of Helium-3. It proposes an alternative theory that the Moon is actually a dwarf star from another sector of our galaxy. This hypothesis is based on the concepts of the subtle magnetic field, SMF, and the relative vacuum of space, RVS, which provide a new framework for interpreting celestial phenomena. This theory redefines our understanding of the Moon, dwarf stars, and the distribution of Helium-3. Traditional scientific narratives posit that Helium-3 on the Moon is the result of solar wind implantation over billions of years. However, this explanation is inconsistent with the broader theoretical framework provided by the unified theory of U, which emphasizes the interplay between the SMF and RVS. This paper explores the hypothesis that the Moon is not a natural satellite, but a dwarf star from a different region of our galaxy, relocated to its current position. According to the book, The Unified Theory of U by L.S. Larkey, the SMF is a pervasive, dynamic field generated by all sentient celestial bodies, including planets and stars. The RVS, on the other hand, varies in intensity across different regions of space. The interaction between the SMF and RVS creates gravitational effects that are perceived differently depending on the local conditions of space. Dwarf stars are formed in stellar nurseries where the temperature and pressure reach extreme levels. During their formation, these stars undergo nuclear fusion processes where hydrogen atoms are fused to form helium, including Helium-3. This process requires temperatures exceeding 100 million degrees Celsius and immense pressure to facilitate the fusion reactions. The intense heat and pressure conditions necessary to create Helium-3 provide a strong foundation for understanding its presence on the Moon. Dwarf stars and their characteristics. Dwarf stars are typically small and lack the mass of larger stars like our Sun. Traditional science measures their gravitational influence through the bending of light, attributing it to their mass. However, this theory posits that the observed effects are due to the intense RVS in their region, not their actual mass. This distinction is crucial for understanding the true nature of dwarf stars and their interactions with the cosmos. The Moon as a dwarf star. The presence of Helium-3. On the Moon is a significant clue to its origins. The Moon, being a dwarf star, retains Helium-3 because of its unique origin and characteristics. The hypothesis suggests that the Moon was once part of a different sector of our galaxy, where the RVS was more intense. This intensity of pressure, influenced by the extreme vacuum of space in that sector of our galaxy, is the true nature of the formation of dwarf stars. The RVS in different sectors of space varies significantly, affecting how celestial bodies are perceived. In regions with a higher RVS, the gravitational effects are amplified, which can be misinterpreted as indicating a larger mass. Artificial relocation of the Moon. The movement of celestial bodies across the galaxy is not a common occurrence and likely does not happen naturally. The hypothesis here is that the Moon was artificially relocated to its current position. This relocation explains the presence of Helium-3 and other elements typically found in stars, not natural satellites. Helium-3, a marker of stellar origin. The theory that the Moon is a dwarf star provides a coherent explanation for the abundance of Helium-3. The high concentrations of Helium-3 found on the Moon are consistent with the extreme temperatures and pressures involved in the formation of dwarf stars. This understanding has profound implications for future lunar exploration and the utilization of Helium-3 for fusion energy, as it underscores the stellar origins of this valuable isotope. Implications for lunar exploration and energy production. Understanding the Moon. As a dwarf star opens new avenues for scientific exploration and technological advancement. The presence of Helium-3, created under extreme conditions, highlights the Moon's potential as a source of fusion energy. This perspective challenges existing paradigms and encourages innovative approaches to harnessing lunar resources. Conclusion. This paper presents a radical reinterpretation of the Moon's origins and composition, proposing that it is a dwarf star rather than a natural satellite. This hypothesis is grounded in the unified theory of U, which emphasizes the roles of the SMF and RVS in shaping cosmic phenomena. By understanding the Moon as a dwarf star, we gain new insights into its characteristics and the distribution of helium-3, paving the way for innovative approaches to lunar exploration and energy production. Future research. Further empirical studies are necessary to validate this hypothesis. Observations and experiments focusing on the SMF and RVS interactions will provide deeper insights into the true nature of the Moon and other celestial bodies. This research will not only challenge existing paradigms, but also expand our understanding of the universe's complex dynamics. Larkey, the unified theory of U.